Hello everyone, welcome to our project. Our project is to digital twin-based sorting mechanism, the waste management. So this one is the metal box, and we actually do not sort that one. It will go on the last way of the conveyor belt. Then there is a green one. We call it as a perishable or food item, and there would be another one that is the blue one. So these three objects we want to actually sort in that one. So this is the objective for this project. So the thing is that we want to do it as a digital twin and not only do that the digital twin, for example, this is the virtual model or we can call it the physical one and we can actually interact with that one from the Stream Data app. From an app you can actually use from your phone anywhere from the world. So that's why we also use a QR code. So anyone can actually scan that one. For example, my other teammate, he just scan it. Yeah. So then you can find that there are some of the options you can actually control from here. For example, right now here is the option for start program and stop program and reset, right? So just I just waiting for the option to come up here. I just push the button reset, then it just stops. If I just start again, oh yeah, it will start. So this is the part, but for the LLD part, I just invite my other classmates to actually discuss that one, how the LLD is working.
So pretty much what we are doing is sorting all the waste like electronic waste, landfill, and compostable based on the QR code that are mentioned on the boxes. And for this, we have pretty much used the same things like start, stop buttons. Here, one thing we have used is the vision sensor that checks the QR on the boxes that enables the operation as to which sorter would turn on in order to sort the other box. Now, we have mentioned some conditions like which introduces so as to if the code is equal to 1, then the sorter or the green box condition turns on. So whatever we need to sort for the green box is sorted in a way that is meant to be. And mostly we have set a counter for all the boxes and that's pretty much it for the LLD. And all the sensor hits are actuation to store the data into the Postgres model. Thanks to MQTT, and Modbus mapping, that we could store all the data to the Postgres. More about the YOLO and Postgres Streamlit configuration, one will be demonstrated.
Yeah, so once we have the PLC program, we configure the mobile for each for input and output. We sending those data to the MQTT to the database for future counting and control like the start and stop. So we could see from the scriptlet over here as my teammate will introduce the start and stop functions, but it also could like detect like through from the vision sensor how many of the blue, green, and the metal being detected, and I also trying to collect the information about the from the diffuse sensor because I want trying to match up the amount between the diffusion sensor and the visual sensor because they're probably making a mistake by the visual sensor detected, but it's sorted to a different channel, so which make the number is different. And I also have the in the streamer I have the query data to show up how many I have to stop auto refresh. So I have auto refresh to make the number be update in per 1 second. And so I have query data to show how many blue box count and green box count in the plots and show the database as well. So I have clear database for alright. So as and then we have found out there's a bug in our not the system but also in the program is if the box is missing during between the sorting and the vision sensor, the system will keep it running because it's keeping waiting for the box is coming. So we introduce the YOLO to detect it on the conveyor. It's still if there's no object on the conveyor for around like 5 seconds, you will reset the system and wait for the staff to restart the program. So now I'm gonna show how it works. Let me double check the okay, right. So I'm waiting for the next one. No, not this one. I can speed up a little bit. All right, this one. So in here, the green box is moving to here, but if the green box is missing, I throw it away. It's missing, but the older system is still keep running. But how we diagonalize it is through the YOLO. So our YOLO is to keep counting. No object counts twice. When it reaches to 8, you will. YOLO is the OpenCV algorithm in here is to diagonalize what color of the object it is, and we import like 50 plus image to fit to the YOLO model, to make it to recognize the metal, green, and the blue. So it could recognize what is on the. Sorry, I have to read because get stuck because it was auto refresh and it uh, the the so this program is compete with the Streamlit. So here I select the region of interest and I can select auto refresh so it won't refresh it. Once it detects up to 8, we'll reset it. I could redo it again. I need to restart it because it reset. Yeah. Redo it again. Restart the program and start running and I haven't started. I'm waiting for this one. Okay, this one's coming. I throw it, and when it start counting and how many round of the null objects being detected, and it will go back to and reset the program and wait for the step come up.
So it gives like the operator to actually work. For example, if there is coming, the operator manually checks what is going on. So whenever he checks that one, that vision sensor can actually help that one to stop the conveyor belt. And whenever the operator is ready, he can again go to the start, like push the button over here, or maybe manually go to the conveyor belt platform and start that one. So that is the functions of the vision sensor that we are putting on over here. Although our LLD is working 100% right, the logical side. So the vision sensor works perfectly, that is aligned with the LLD here as well. There are some of the challenges that we face over here. For example, as my teammate showed, that some of the data while it is coming, there is a latency we have found, like sometimes we need to actually refresh that one. But we believe for future, if it is a virtual platform, we actually communicate with the HTTP request or API. If it is like the for the wire connections of that one maybe very much low latency, so that might be help to actually resolve that these kinds of operations. And another thing in the factory IO, we have found the challenges. For example, the sensor and their position. First, we use like reflective sensors, but after that, we found that there is a position. This is reflective sensor, so it needs to be positioned accurately. Then we change the reflective position to the diffusion position, and also there should be a timing, but we do not put the timing, we put only the logical system. That's why you are putting like 3 different diffusion sensors. For example, any of the metal part or any other part, if it is just cross this line, then it will actually come or have the chance to go start the entry container. From here, the other parts will come. So this is the overall project and the future work that can be done from this. Thank you for enjoying our project.